Hi. So I don't know too much about the project, except there's an interest in some sense of reproducing Spiral5. So I'm going to go through a kind of review of the system components and a little bit about what the structure, what the control user interface. It was a performance. So I don't know if recreating the performance means you recreate the environment which you could perform the piece, or or if it's going to be, in a sense, a kind of riff on Spiral5 based on whatever technology you can put together to try to capture the spirit of the situation. And all of that's fine with me. I don't have any problem with whatever you decide to do with it. This is the analog image processor, the IP. It's a patch programmable video synthesizer. Takes video signals in and can add them and multiply them and do things like a TV special effects generator. It's structured very much inspired by the Moog Model 2 audio synthesizer, and at some point I can go over that in more detail. There is a functioning one in Chicago at the School of the Art Institute, and they actually teach courses using it. So they're actually, and I give a lecture at that course typically every year, so there'd be a chance to actually see one in action. I have one upstairs in storage, which is my personal IP, if you just want to see what it looks like physically. There in the center is Tom DeFanti and me, and this is, you'll hear more, the vector general display, the visual output of the PDP-11 vector general system, and there's a TV set that has some output of the IP. And over here, this is from Spiral3. Spiral5, there are 5 performances. The 5 stands for the 5th performance, and that on the left happens to be an image from Spiral3. So in '69, I was invited to come to UIC's art department and bring computers into the art curriculum, which again was pretty amazing because people are still arguing about it. I teamed up with Phil Morton in 1971, who's a very important component of this activity, and also March 7th at the Gene Siskel Film Center is going to be, and I'll check that date, but I believe that's right, a kind of retrospective or a program about Phil Morton and about some derivative works of Phil Morton, if you want to follow a little bit more in the tradition of this stuff. And Phil was a collaborator on all of the Spiral pieces, and his name is attached to all of them. See here. Okay. So there's another picture of the IP. In '72, I did the image processor. Dan and Phil documented it, gave away plans. About 20 copies of the IP have been generated and were in use, and it was a large kind of active community of people doing this. It was kind of like an open source hardware distribution idea that was quite effective. And then 1973, Tom DeFanti came here to UIC with the Grass System, and we were supported as kind of a short order media house for education and research. That's where the money came from. And there was a series of electronic visualization events in '75, '76, and '78, which were live performances with the equipment that I've reviewed here slightly before audiences. And here's a picture of the crew for Eve 1. And you can see it's actually quite a few people participating at various levels. We had a number of pieces performed, and typically each one of us was involved in 1 or 2 pieces, and the rest were involved in other aspects of it. I'm going to, because I discovered I had some MPEG-2 noise, I didn't do a good enough job in coding, so I'm going to go back to the AVI file here. Interrupt the flow a little bit, but get a little bit better video.
Spiral5. It was actually a combination of 2 systems, the analog image processor here and a computer graphics system developed by Tom DeFanti. So let's jump to some tape about that system. Hiya, Tom.
A little cook's tour of this laboratory in the chemistry department. We'll take you over the computer here. This single bay houses the graphics computer, And this down here, of course, is the PDP-1145 computer. Behind this panel is 28,000 words of memory. This here is the disk drive, the mass storage.
5 megabytes.
Used to hold pictures and macros and other information used to run the graphic system. Up here is the A to D converters, which allow us to use dials and knobs and sliders and other things to control images. From the computer's memory go wires that go over to the vector general. And as you can see, the vector general is capable of putting up images in real time, rotating them around. What we do there is point TV cameras at them. Little TV cameras like this, which you can move around and center and get different parts of the screen. And then, because color is much more fun than black and white, we run cables over this way to a very colorful person, Dan Sandin, inventor of the image processor.
Spiral5 was created by Tom DeFanti, myself, Dan Sandin, and Mimi Chevets doing sound. Yeah, that one's nice.
Yeah, but what happened to it?
Between 1975 and 1980, there were a series of live video computer performance events at the University of Illinois at Chicago. The first was the Interactive Electronic Visualization event in 1975, followed by EVE 2 in 76 and EVE 3 in 78. During this period, there were a total of 5 performances of Spiral, the last of which is Spiral5, called Spiral5PTL for perhaps the last.
Which it was.
What follows is a document of the performance of Spiral1 at the first EVE event. It was performed in April 1975 and is introduced by Phil Morton.
The name of this entity is Spiral. Digital keyboard by Tom DeFanti. Analog computer, Dan Sandin. Sound keyboard, Bob Snyder.
Goodbye, Phil.
So going on to talk about it a little bit. Um, there's two major elements, or three major elements in it. There's the image processor, there's the graphic symbiosis system, and then there's sound. And the IP is a patch programmable video synthesizer, one of a number that were being developed during that time period. And there is a modern version which is quite close to the IP, in fact has some modules in it named after myself and the IP. So it's still a current thing. The Grass System, and I can actually tell you, I mean, I know what patch, I know what program I had up on the machine when I did that performance, because pretty much developed a patch and used it in variations for work at that time period. And there's much more information about the analog IP that, if you need it. The Grass System, Grass is also, the Grass language is a real-time interpreter. It very much has similar goals and similar rhetoric to around processing in terms of being a language designed to be used by artists, to be able to do interactive and particularly interactive things, but of course always fixed compositions are possible. The performance in the IP was actually turning dials and sliding sliders. I didn't change the program in the sense of changing the patch. I just turned knobs which enabled parts of the program to be visible. In the Grass System, the performance part was turning those big dials you saw and sliders and a series of buttons. The sound in Spiral 1, 2, and 3, it was live with the Fender Rose electric piano played by Bob Snyder, or Sticks Rabone, as his alias is. He's a professor at the School of the Art Institute in the sound department, was then and still is. The sound for Spiral 5 was conformed. We performed, Spiral 5 was not performed before a large public audience because we decided that the demands of running a large public event kind of impacted our ability to do high quality work. So the final of the eve performances, the productions were done in front of studio audiences, and there was compilation tape which was played before a large audience. So for Spiral 5, there was sound done by Mimi Chavez that we performed to, but the actual soundtrack you heard was conformed to the visuals using that instrument there. Now, the Vector General Display is a hybrid analog-digital system. The PDP 1145 sent digital information to the Vector General Display, and the Vector General Display performed those instructions in the analog domain with multipliers and integrators and differentiators and what have you. So it was actually a hybrid analog digital system. PDP 11 processed the language and sent the endpoints of the vectors and the transformation matrices to the display, and the display did the transformations in the analog domain. It happened to be an orthographic display. It was not a perspective projection. That actually dramatically affects the way those images come out in this case. And it was a colographic display. It drew bright lines on a screen, and then it drew them again, and they faded out, and it drew them again, and they faded out. So it continually redrew those lines. So one of the wonderful things about it is it was as easy to change as it was to do the same thing. So it was a very natural real-time display. And then phosphor persistence, the fact that the phosphor took a while to decay, minimized flickering, and actually gave rise to a number of the visual effects that you saw there. The interface to the IP, there were kind of multiple cameras with their own persistence. Those cameras of those time periods, actually the image did not get completely wiped off when it was read out. They were called Vidicons, and so there was actually persistence of vision, so to speak, in the cameras themselves. Those cameras were connected to the IP, and the output of the IP was connected to a 3/4 inch tape recorder. There were no pixels anywhere. no pixels, holographic display. But actually, when I finally copied from Betacam SP, which is an analog, a professional analog video recorder, to DVCam, at that point I got a 720 by 486 grid into the system. So let's talk about what it would mean to try to approximate some of these systems. And I think the IP, if you had control surfaces combined with a data flow programming paradigm, in other words, the idea of patching modules together, which is common in a number of performance systems still, and then had real-time processing modules that could do bi-component image addition, multiplication, differentiation, RGB table lookup, function generation, would pretty much duplicate the IP. The multiple oscillators for pattern generation was an important feature of the IP. They're a fairly minor component of this piece, but I actually had to add that line because I noticed in the opening scene there was this fine little Venetian blind looking pattern, which was a pattern being produced by the IP. But probably the most critical thing in a way is not part of the IP, but would be something that simulates the interface between the vector general and the IP, and that would be something that does frame-to-frame rolling integration over time. So if it takes successive frames and decays off the history, kind of the accumulation buffer would be the OpenGL device that you would use to do this, with the older frames falling off by an exponential. Would actually, I think, pretty much simulate the display. That input fed to the processing capabilities of the IP, of course. So I really think the interface probably is, which probably belongs primarily in the IP simulation, be the same kind of stuff that's necessary for the IP. Now, the visual phenomenon of Spiral 5, the reason that last thing I talked about is so important, is that really very much the core of the visual experience has to do with this phenomenon of, of essentially temporal aliasing, sampling at not fast enough, sampling of transforming objects written to a decaying phosphor display. And you can see really quite long-lived things. For instance, if we go over here to the right, I mean, these things were probably tens of frames. It's an exponential fall-off, so it like hangs out for a long time near the bottom. And the IP is one of the differences between the left and the right image is that in this case what the IP is doing is turning the bright down and bringing the dark up in part of its processing so that you see that history. You wouldn't really see that much history looking at the display itself without the image processing component afterwards. You can also see that there's a brighter history. All these dots are sequential frames of points being written. By the way, although the vector general could draw lines, and we did draw lines for most applications, in this particular application it was just drawing points. And you can see those dots you're seeing that are following paths are successive frames of drawing points while the object is being moved and rotated. So it's a very critical, to get the look. Now, to have a wonderful play space without this phenomena would be perfectly interesting too. I would find it kind of dry. It would be like listening to music without any reverb at all, or listening to music that's all done by simple oscillators or something like that, rather than kind of the timbre of complex instruments. But it might be a more feasible thing to do. But I think this is not impossible to do. So now approximating the Grass system. The Grass language, as I said, was designed by artists. It was a real-time interpreter. Details of the language can probably be found. I was not able to find my manual of Grass. I was able to find documentation of the successor languages, which were ZGrass and RT1, which carried forward into the frame buffer domain the language and had many of the same properties. But to give a little bit of the spirit of what was going on with the language, and again I'm going to go back to the original for because there's less MPEG noise and more snow, more of video analog noise, which I just prefer in this context. wrong one, no wonder. Okay. And I'm going to jump along to where they start showing the language use a little bit. There's Phil. It's an important part of the game, and of course Tom.
Hey, Cross-Eyed, I've been reading this paper here we wrote for the
Oops.
conference, and it gives a pretty good idea about the technical and computer science type things we did in this laboratory.
Notice we're on take 41 now.
A very good
42,
idea how much
43.
fun it is around here.
But we can look at all of that too, but what I wanted to get to, since we've seen part of this, what you saw was a compression of that.
Performance context.
Live from Chicago, Illinois, it's Saturday night. Welcome to the second electronics visualization event. The first entity this evening is digitally done by Tom DeFanti and Drew Browning, analog by Barbara Sykes, and the audio by Sir Michael Sterling. The title of the entity, Circle 9, Sunrise.
We're not going to see that. But you can kind of see again the context of it.
The single thing that's hardest to communicate in a paper like this.
This was a presentation of the National
interactivity in the
Computer
system.
Conference. 70, whatever I
For
said.
instance, anything that can be controlled in the system can be controlled through the use of slide potentiometers or dials, like these. What we're going to do now is show you how we make up simple objects like this. But first, you can see the room lights reflecting in the screen, so we normally work with the room lights off. The room lights are actually still off. What we've done here is put up some infrared lights, and Cross-Eye over there has an infrared sensitive camera, so we can show you the working environment of the room while we're actually doing things and still get high quality video without the room lights. The regular TV cameras are not sensitive to infrared light. First thing we have to do to show you how we make this little flying starch molecule is restart the system. We're also superimposing the BTO5's type on the screen.
Of course, the IP is doing that.
We get the starch molecule up. And we get the propeller from the disk. The first thing anyone does with propellers is rotate them. But that appears to be the wrong axis. The system is very good in letting you know when you're wrong right away. Now we want to attach the propeller to the front of the starch molecule, so we have to move it. That's easily done. However, we have a problem with the z dimension because we can't see it here. On this display, you can only see z-axis information when the object is rotating. So what we're going to do now is group these two things. And we're going to call it Dan. Grouping allows you to manipulate both objects independently and as a group. So we're going to rotate so we can get z-axis here. And as expected, the z is not lined up. So we move it over like that. Now, no matter how hard we wiggle this, the propeller will not come off. Now we want to get it back to that kind of elliptical orbit we had before. So we'll use a multi-dial rotate. In this case, we're going to use the slider pods. And it's not quite arranged properly on the screen, so rather than move the TV cameras, we're just going to move the object. This time on the tablet. And it's a little too big, so I think we'll scale it down. Dial 1. so we have complete control like we had before of speed and things like that. Now, although it's not particularly didactically or aesthetically important here, we very often break up objects into multiple colors because you do get more information that way.
There's more
Where
detail
we
here,
generally get
but
two colors
I
in this
just wanted
laboratory
to
is by using two TV cameras.
have a few grass statements typed in. You can also type programs, and then you sit there and give it a name and make the appropriate braces and write the program and hit return, and it'll run too. It'll fly off. So it isn't just individual statements. And it has a number of very interesting functions, which independently of this particular project, I think would be informative in terms of developing languages to do live performance. All right. Something strange here. Well, that didn't read. So I have a program here. So the only primitive, that's weird. How did that happen? Looks fine there. That's what I get for not doing 100% rehearsal. So the only primitive used in this performance is a linear spiral. You could make it with something like that, where you have, x and y as sines and cosines, and radius is increasing with theta, and z is equal to radius. So it's really kind of a cone-shaped object going back in space. And you saw that a whole bunch of times. That's actually the only primitive used in the piece, as far as I know. Other performances used more combinations, but that's it. But of course, the dials could be attached to various rotation rates of both individual elements and of various groupings of elements. The buttons can store and retrieve combination of rotational rates and group configurations. You'd find something you liked that was producing one of these wonderful, patterns that are produced by this temporal aliasing, and where you have these other things moving slowly. Sometimes things are moving backwards, like temporal aliasing style effects. And then you push a button to store that configuration. Then you could linearly interpolate all the variables to that destination set on another button. So the buttons were essentially used to store and retrieve sweet spots that you found in the process of experimentation or performance, and then you could get back to them. And that's really pretty much what the performance was. That's it.
So when we saw those spirals and we had the two screens, one that was very bright and one that had the centers of the objects dark, was it actually drawing the dark one every frame, but the result of the bright one because of the decay?
No, if you imagine, one of the things that the image processor can do is it can map a function like a lookup table of the images coming in. So what I really did there was to take the bright stuff and turn it down so it became dark, and the dark stuff and begin to turn it up so that it became more visible. So that was done as kind of an image processing activity that the analog image processor did to be able to emphasize. And what's interesting about having that kind of function table lookup, since stuff's decaying to zero, when you start bringing the dark stuff up, you're actually bringing history up. You're bringing up the history of what's been done before in that system, and that's how you get all these sort of very complex looking combinations.
Ask any questions before we start the discussion?
So was the output fed back into the input of the system? Or?
Not at this point. Although in Spiral 3, where you saw, in the performance of Spiral 1, where I showed you got an idea what the live performance was like, there was feedback going on there. That I had fed the output screen got fed back in. You see those characteristic patterns. But in Spiral 5, there was no video feedback.